Hi, my name is Brady, and today we're going to be talking about CVE 2026-54121. This vulnerability was dubbed Certighost and was patched by Microsoft in mid-July of 2026. This past week, the researchers associated with the vulnerability have released a proof of concept script, so we're going to be diving into that proof of concept to discover how the vulnerability works. Before we do so, though, I think it's important to note that I'm not a part of the research team, so all credit goes where credit is due to the researchers themselves. And with that out of the way, let's go ahead and jump into the research. So here we have a GitHub gist released by the authors. So they are Hojen and Anik Fakrul. Apologies on those pronunciations. I'm certain I got at least one of them wrong. But they talk about kind of how the vulnerability works and what the proof of concept exploit does. So scrolling down, we can skip a little bit of the intro stuff. This involves Active Directory certificate services, and I'm going to assume that we know how that works to progress through this video. Jumping down here, we can talk about the LDAP chase. So how the bug works is that in some cross-domain controller enrollment scenarios, the CA may perform a second directory lookup, referred here as a chase. So in some cases, the certificate authority or the CA might be looking for a principal that is not associated with its home domain controller. So it may have to reach out to another domain controller to find out the details of that principal. And what we're going to talk about here is this LDAP chase, which involves these two attributes, the CDC or client DC, which identifies the host that the CA should reach out to, and then this RMD or remote domain, which identifies the principal the CA should look up. So when we see CDC, we're thinking this is where we're reaching out to perform our LDAP chase. And then RMD is going to be the principal that we want to target. Now, scrolling down through this research, we can see this is kind of a flow chart of the vulnerability itself. So let's go ahead and use that. So what's going to happen here is we're going to create a machine account, and the proof of concept will actually do this for us, and I'll explain that in just a little bit. So we will create a machine account. This machine account is then going to be accepted as a domain principal. Now, the reason we need a machine account is because we're going to be requesting a certificate from the machine template. We need an account who can actually request from that template. Then we're going to submit a certificate request with our CDC and RMD attributes to the certificate authority. That certificate authority is going to connect back to the CDC, which remember is going to be our attacking host, and it's going to perform that LDAP chase using the RMD. So it's going to look for whoever we tell it to look for. We're going to return that target DC, which the proof of concept exploit actually pulls way up here. It's going to reach out and ask the domain controller about this information. So we will return the target domain controller's object SID and the DNS hostname. Right here is where the vulnerability actually takes place. So this trust boundary failure occurs when the remote chase response is actually treated as authoritative. So it doesn't check to make sure that we are who we say we are. It just says, well, you have this information, so I might as well give you a certificate for it. So then it's going to issue a certificate with the target domain controller's identity, and we can go ahead and authenticate using that certificate. And then we can do all the things that a domain controller can do. So we can do our DC sync attack and take over the domain. There's a little bit more to this research. They talk about how the vulnerability works, the steps to exploit it, and then it tells you what the proof of concept does. We'll be covering that in the video, though. The gist also includes information about what happens after you update. So if you patch the vulnerability, it'll tell you what the differences are. We won't be discussing that in today's video, but I will link the gist in the video description so that you can check that out. It also discusses what the patch fixes and how to apply the patch down here at the very bottom. Linked down here at the bottom is the Certighost POC script, which is over here. I've already cloned this to my attacking machine, so we will go ahead and skip that step. Let's jump over to our terminal and discuss our lab environment for today. So we have ADCS DC01, which is our domain controller, and then ADCS CA01, which is our certificate authority. So something that I found in my research that's important to note is that the CA needs to be on a different machine than the DC. And the reason for this is if the CA reaches out, but it's reaching out from the DC, it's going to reach out with the DC's machine account, which is a trusted account, so this authorization will fail. With that being said, we're not going to explicitly touch the CA. The proof of concept script is going to do that for us. So the only thing that we need to worry about is the IP and hostname of the domain controller in this case. So in today's lab, we're going to be using this domain user. It's a low-level account. You can see down here, it's only a member of remote desktop users, and that's just for convenience. It doesn't have anything to do with the vulnerability. So with this vulnerability, you can escalate from a low-level principal with no privileges all the way to full domain takeover. So here I've cloned the repo. You can see here, all it has in it is the README and the certighost.py script. Now, because of the way that the dependencies work, I've went ahead and created a Python virtual environment. So that's what this Certighost is. I'm going to be running everything through that virtual environment, but it can be run just using the instructions that are on the GitHub page itself. All right, so what does the exploit look like? So this is going to be the syntax here. We're going to run this with sudo because we're going to be starting a rogue LDAP and SMB server that's going to run with super user permissions. I'm running here through my virtual environment, but we're running it with Python 3. The domain supplied, in my case, is going to be this fakecore.lab. We'll use our domain user and password, and then we'll provide the DC IP. And we'll go ahead and run this here. going to ask for my sudo password. And you can see it is running here. And we got a successful pull. You can see it connects to LDAP-S. It's going to detect infrastructure for us. So it finds the DC, it finds the CA name, and it tells us where that CA is. It's going to find our target principal, which is the machine account of the domain controller, and it gives us that machine account's SID. It's going to create a computer account, which in this case is this ghost and then long string $. It's going to start up our rogue servers. It'll request a certificate using the machine template, and it's going to provide the CDC attribute. Now, it automatically detects with a route to the domain controller what IP to use. So this is my WireGuard IP in this case. And it's going to get a certificate. It's going to save that as this ADCS DC01.pfx. It's going to perform pkinit as DC01, and then it's going to get hashes and a TGT. And then it gives us GGWP. Now that we have our certificate and our TGT, we can use that TGT for authentication. So I'm going to use it here with KRV5CC name. ADCS-DC01.ccache is the file that it output for us. We're just going to run secret stump using Kerberos, so we have no password. We're just going to dump the KRV TGT account on DC01. You can see we run that here, and it gives us our hashes. So this represents a full domain compromise. Now, just for illustrative purposes, I've made this modification to the script here. So I'm just adding this printf line that's just going to show us the attributes that it's supplying. So let's go ahead and run that again. And you can see when it sends its request here to the CA, it's supplying certificate template of machine, this subject alternative name of our DNS name, and then the CDC, which is our IP address, the RMD, which is the target principal, remember, is going to be ADCS-DC01, and then we get our certificate and our TGT as normal. A couple of things that I wanted to note about how this works, it actually does create the machine account automatically for you, but you can use it with a machine account that you already control. And I kind of like this because it gives you the machine account, but it doesn't actually give you the credentials. So this machine account that we're creating is kind of a one and done. It's used just for this, but we don't actually get the credentials until, if we succeed, we could DC sync, but it doesn't give us anything in the tool output. So if we wanted, again, assuming that our domain user can create machine accounts and that we have not yet exhausted our machine account quota, we could just use something like Impacket to add a computer. So I'm going to use add computer. We're going to add this test $sign with a computer pass of test machine pass. And you can see it was successfully added. So now we can go ahead and run this. So we're going to run it with our same domain user and password. This time we're going to use the TAC computer name, and that's our test $, that we just created, and then the computer pass. And you can see it's going to work just like it did before. Now, this does kind of make you wonder, what if the only credentials I have are this machine account? So we can go ahead and try that here. We've got our domain name. Our username this time is going to be the machine account. So if we just stumbled upon a machine account in some cases and we don't have a low-level user that's not the machine account, we can actually just use it just the same. So username is the machine account. Again, our computer name is the test $sign and the test machine pass. You can't just supply it here. It won't recognize if this is a machine account or not. So you do have to supply it in computer name and computer pass. But as we would expect, it works just the same. But that's pretty much the long and short of the video here. Once again, credit where credit is due to the authors who discovered this vulnerability, disclosed it to Microsoft, and actually got it patched. If you want to check out how to patch your systems, make sure to check out the end of this gist, which will tell you how to fix it. But that was just a demonstration of how the proof of concept exploit works. Thank you so much for watching, and I'll catch you in the next video.